Hello and welcome. My name is Kasim, and I'm a senior data scientist at Johnson Snow Labs and the CTO of Dijkstra Labs. I've been working in data science and big data for almost 10 years now, and today I will show you one of my most recent creations, the NLP library. It gives you the power of over 4,000 models in over 200 languages at state-of-the-art accuracy in just one line of code. And to understand NLU, we must understand Spark NLP. It is a big data library focusing on being the most accurate, scalable and fastest library out there, and since its release, it has accumulated millions of downloads, become the most widely used NLP library in the enterprise, used by many honorable customers, and has been awarded continuously by the industry. And if you look at all of the features provided, you can really see why that is so. And today, I will show to you how you can leverage any of those features in one line of code with NLU. All you need to know is that there are two methods. The NLU.load method that takes in the string parameter and returns to you a model object, and a model.predict method that predicts on your data. And so more concretely, you can say NLU.load emotion and then model.predict I love NLU. And this will give you a pretty pandas data frame with all of the emotional confidences and a correctly predicted class of joy. Analogously, the named entity recognition lets you extract named entities like Donald Trump and Angela Merkel and label them correctly as persons. Or you can even get the latest of the Bertology embeddings like Bert, Albert, Roberta and more in just one line of code. And all of this works on the most common Pythonic data structures like strings, lists of strings, and even Pandas, Spark, Ray, and Dusk data frames. And one of the most recent additions include text summarization and question answering via T5, Marian NLP for translation between over 200 languages, the language agnostic BERT, which you can use to train an NLP model that can understand over 100 languages, even though it was only trained in English. And finally, you can train your own embeddings in Hugging Face and bring them to NLU or Spark NLP. And now we come to the demo segment. To have fun with the demo, I invite you to play along with me and just Google John Snow Labs NLU. And then you can open up the very first link that leads to GitHub. And in there, you open up the examples folder. And in there's a webinar and conferences folder. And in there is the AI 421 conference folder. For us today, together with the NLU crash course, I will give you today, which will showcase you all of the features that are truly powerful. So you click here and click on open a new tab, which will open up a Google Colab environment where you can run all of the powerful and large models for free on Google's machines. To get started, you just hit install and this will install everything for you, and all the code we will be using is down below. But to make it a bit more interesting and spicy, I have removed all the code and I will show you live how easy and fun it is to play around with NLU. So we start with import NLU, right? What comes next? We say NLU.load, and let's say we want to do spell checking, right? So we say spell, and then we can predict on a badly spelled string like I live to live dangle to, and we run, and we see the spell check DL model download has started, which is a deep learning architecture for spell checking. We get the spell checked version of our input string. So we see for each input token I live to live dangatus, we have here the spell column with the spell checked version for each token. So we have I like to live dangerous. Wonderful. In the next segment, we have the sentiment classification. So how do you classify sentiment? You just need to know the name of the model. So you just say NLU.load sentiment, and then you say .predict I love NLU and AI 4. And then you hit enter and you see the glove-based model is being downloaded, and in a few seconds we get the sentiment classification result. And in this case we get the output of positive and a confidence of 99% that we are actually happy about NLU and AI4. Wonderful. On the other side you have more grammatical features like the part of speech, which you can see here define various grammatical classes for each token in a sentence. So to get these you can just say NLU.load POS for part of speech, and you can predict on POS assign the token in example and grammatical label. And we hit enter, see the model is downloading, and we get the predicted parts of speech for each token. Wonderful. In the next segment, I want to introduce to you the named entity recognition, one of the most powerful tools in NLP. And you get it with any R. What it does is it predicts for the segments in your text which belong to specific classes. So you have the one on the one side the 80 class NER that can extract for things like Donald Trump and Angela Merkel don't share many opinions. And then if you run this, you will see the named entities extracted, which are, in this case, two entities of the type person Donald Trump, which we see here in the entities column. Donald Trump is the first entity, and Angela Merkel. Very powerful. But let's now actually see this in action. For this, I have prepared a little Bitcoin dataset for you with headlines of Bitcoin or crypto-related news headlines. And we will see how powerful these NLP tools can be on an actual data. We download it here, and then we load it into a pandas data frame. And how do you apply it? NLU to a data frame. It's very easy. So let's apply NER to a data frame. We just load the NER model and then we put in the data frame, and we just need to specify output level is equal to chunk, and then we call this NERDF and then output this in the next row. We have predicted for every Bitcoin news headline the entity class of it. And to get proper insight into the Bitcoin dataset, what we can do now is we can just say NERDF dot entities class dot value counts, and this gives us the most occurring entities, and we want the top 50, and then we say dot plot dot without the brackets dot plot, and then we say fixed size is equal to 2060, and this will show us the distribution of the named entity class. And it makes sense as most of them are cardinal, a number, but there are a lot of countries and organizations and even persons. And now we maybe want to know who is the most talked person in the data set. We just type NERDF at position NERDF dot entities class is equal, and now we say we want the class person, and then we say dot entities, and then we say value counts for the top 50 or 100, and then dot plot dot bar h, and we say fixed size is equal to 16 and 20, and this will give us the distribution of the person entities, all the named entities of class person. And so we see Ross Ulbricht, George Weiss, Richard Branson, and so on. If we want countries or states, well, we just swap this line with GPE, and now we get a distribution of countries, and we see China, US, or UK. How do we do that with product? We just type product, right? And this works with all of the 18 classes, and we see one of the most occurring products is Black Market Reloaded. Or let's look at organizations, and there we can also see the distribution of organizations, and we see, of course, Bitcoin, CNN, the Senate, but even here and there things like the Feds and even the FBI. Crazy things. And so with just a couple of lines we have explored this Bitcoin dataset and know what is up in there. There's just another algorithm, and that is the Yak algorithm. So let's just load it. How do you load it? Just by saying nlu.load Yak, and it will get us in an unsupervised manner all the keywords in the dataset using various statistical analysis. And we get the keyword confidences, and for each sentence keywords like update, China, and need, relating to the news article, of course. And how would we visualize this? We just say yakdf.explode, and then we say keywords, and then we say again keywords.value counts, and we want the top 100 keywords, and plot.8 with a fixed size of 2016. And this will show light to us now the distribution of keywords. And of course, the most occurring entity is Bitcoin, Bitcoin price, market cap, and so on. So really very powerful tools. On top of this, we can even do the sentiment analysis. And so how do we do that? It's just nlu.load sentiment, and then we store the results in the sentiment df, and it gets back to you a data frame with the sentimental predictions and class. So we can then easily plot this, and if we say sentiment.sentiment.value counts, and then we just say plot, or just say plot, we don't even need a bar, and we now have, we actually need a bar, but not a bar H, and we see it's mostly negative, a little bit positivity. And now I hope you see the pattern. Let's say we want the emotional analysis, so we just swap this for emotion, and we call this here emo.df, and we just say the output level is a bit different. We just say here output level is equal to document, and run this, and we get the emotional data set returned with all the 4 class emotions predicted. And to visualize this, it's really easy. We just copy paste the code from before, swap the emotion variable name, swap sentiment for emotion, and now we have the 4 class emotion distribution in our data set. Perfect. So the final section we cannot actually run in our given time frame, but we can look at the pre-computed outputs in the notebook. So let's scroll down a bit to where we left off. And here is the T5 question answering section. You can load the T5 model with en.t5 and ask it simple questions from the closed book domain, like who is the president of Nigeria? And it will tell you Muhammad Buhari. Or if you ask what's the most common language in India, you will get Hindi. Or you could even ask what's the capital of Germany, and T5 will tell you correctly Berlin. Even cooler are the open book questions, where you can give additional context. Like in this example, Peter's last week was terrible. He had an accident and broke his leg. And then this the context, you can ask on this context, why was Peter's week so bad? And T5 says he had an accident and broke his leg while skiing. Or if you ask how did Peter break his leg? Well, while skiing. And on top of this, you can even define a news article and ask questions on this, like this little Alibaba article, and you can ask who's Jack Ma, and it will tell you Alibaba Group founder, or who's the founder of Alibaba Group, Jack Ma, and so on. So definitely take a closer look at this, because you can really leverage all your data sources and make them available to all your users. And T5 has a lot of additional things it can do for you. One of the things is text summarization and question answering, what we have seen, and a dozen of other tasks which fall in the NLP domain. But we will now just take a closer look at the text summarization, for which you just need to call en.t5 base and you get the T5 model, and you need to set the summarize task and then predict on this little news article which I've prepared, which is 1300 characters long, and the summarized version just a little bit less than 350. And so we already have reduced it by a very large amount, and if you have the time, pause the video and see that really all of the content is still there. And now following that, you can easily translate with the Marian translator model. You just need to call en.translate to DE, and then this will translate for you to German, in our case the Bitcoin news article. Or if you want Chinese, you just say en translate to ZH, and here we have in the translated column now Chinese Bitcoin article. Or if we want Hindi, we just say en translate to HI, and now we have the Hindi column. And finally, you can even train a multilingual classifier with the Labse embedding, which will support all of these languages. And in this example, we just train on a French data set our sentiment classifier, for which we have positive and negative labels. You get trainable classifier by just saying train.sentiment, and if you specify before that some embeddings, you will get, in this case, the multilingual Labse embeddings, and you can set the epochs and the learning rate and train for a while, and you get very nice metrics. And the best thing about this is that if you test the model, it will properly predict on all of the 100 languages. So you can see it predicts this English string, or if I give it the string der Film war echt klasse, it knows that's a positive German text, or even the Chinese language, or Vietnamese, Japanese, and so on. So really, there's so much to discover. I definitely want to encourage you to check out the Nlp Models Hub, which showcases you all of the 4000 models we offer in all of the 200 languages, which you can filter here, and you can even filter by task. So let's look at all the text classifiers, and then you could click on the track question classifier. Then you just open this in a new tab, and then you have a little card describing and documenting everything you need to know about this model, and an easy one-liner for NLU. So now we come to the final segment of today. So we just head to the NLU website, click on Streamlit, and then make sure you have sklearn and Plotly installed, and all you need is this one-liner. Open a shell, paste it, hit enter, and you're ready to go. Our Streamlit app will pop up and finish loading in a few seconds. So now that our data science cockpit is loaded, we can actually have a closer look at it. So what do we have? In the middle, you have the inputs, the outputs for each of the 7 Streamlit building blocks that let you play with all of the 4000 plus models. On the left side, you can configure all of them and even get additional metadata and links to the documentation. But first, let's look at the visualizations. So first of all, when you input it here, it will be passed to all non-embedding based visualizations. So on the one side, we have the named entity recognizer, which will detect and highlight the NLU organization entity. Following that, we have the typed dependency tree structure, which has the dependency structure as edges and the labels for them visualized, together with the part of speech tags below. Following that, we have the token features, which give you actually access to all of the 4000 plus models here by just selecting the right one on the left side here, and it will output to you all of the predicted features. So you really see what you get, and you can try before you buy with the NLU library. And in the text classification section, you can actually see just the classification results. And in this case, the only classifier we have loaded is the NER classifier. And so we see the NER classification results, of course. And after that, we have the semantic similarity matrix. That shows us for two input strings, so on the one side the I love NLU, and on the right side the I love Streamlit, we see how similar each token is to each other token based on the similarity metric used to compare the word embeddings. So in this case, we use the cosine similarity and use the GLOF 100D embeddings. But we could easily use any additional word embedding and even any additional similarity metric like Euclidean, L1, Manhattan, and so on. Overall, we have 7 of them. And last but not least, we have the dimension reduction techniques you can use to visualize your embeddings in 3-dimensional dimensions or a 2-dimensional plane or even just a 1-dimensional plane. And this lets you actually interactively look at the embeddings and even compare them. And in this segment, we have on the one side in the top row, we have the word embeddings of GLOF reduced with TESNI, and in the bottom we have the PCA algorithm. And you can pick up here from over 10 different techniques from the sklearn manifold learning package and the matrix decomposition packages. And we will see in a second how this is very valuable to really understand the contextual knowledge of our embeddings. But let's play around with this a little bit more. So let's say I input the string I love Paris and I hit enter, and we see all the visualizations get updated. We see the named entity Paris gets detected and the part of speech tags are also defined for this and the tree. And of course we have the new token features and the text classification result. But let's say we now want to add a sentiment classifier. So I just type sentiment and this is searchable and shows me sentiment, and then I can just add Peter hates swimming and I add this and we get the sentiment classification results. So we see the first sentence was positive and the next sentence, the Peter hates swimming, is negative. And on top of that, you can even generate code snippets. These code snippets can be copy pasted straight into your Python script or notebooks, and they will give you all the NLU models you are playing around with interactively. So you don't even need to know what code is generated or used. You can just copy paste here and get all you need. And even on the left side here, you can load the entire pipeline with the first command, and you see here you have dozens of links for all the models loaded and can actually read up about the metrics and the accuracy of these models and how they were trained. Cool. But now we can get our hands actually a bit more dirty with a proper NLP example. So we just open up Google and we search for American presidents, and we open up the first Wikipedia page, which gives us a data set of all the American presidents. And we are going to play around with. All we need to do is hit Control A, somewhere copy, and then you go to your NLU application and hit paste and then hit enter. Our entities will be finished loading. And we can see now we have analyzed the entire Wikipedia page for named entities. And we can see everywhere president person entities like Richard Nixon or John F. Kennedy are popping up. We even get dates, all various persons, especially from the citing, we extract the names and the dates. And this all is very, very powerful. And so let's try this out for a couple more languages. Why not go with Russian? Hit Control A, copy, and now we can paste this and our entities get visualized. But wait, our entity recognizer doesn't understand Russian, right? It was just an English recognizer. It might get the dates and cardinals, but we can actually use the Russian NER model. And how do we do that? We just type up here the prefix, so we just type RU.NER, and there are even multiple NER models. And we just pick the default. We will get the named entities recognized by the Russian named entity recognizer. And we can already see there's much more information extracted. And we can actually tag the Russian names of the people and the Russian location and the Russian MISC entity. So we already see with just one click, we just were able to try out the Russian entities. And we can really see there's so much knowledge extracted and with really just 0 lines of code. So why not try this for a couple more languages? Let's go with Turkish. So let's go back to Wikipedia and go to the Turkish page and then hit Control A, go back to our website, hit Control V and then hit Enter. And we can see the result of the NER model, but we see this looks a bit messed up. And why is that? It is because we are still having loaded the Russian NER model. And how do we switch to Turkish? We just click over here, we type tr.ner because that's the prefix for Turkish, and we could now pick from a variety of Turkish NER models. And we just take the first one and we get the results of our named entity recognizer for Turkish. And we can see now all the Turkish named entities are now properly being predicted within the Turkish text. So this is already very powerful. And let's look at one more example. Why not try some German text? So we go back here, we go to the Deutsch section, which is German. We hit again Control A. First of all, we clear this up maybe, and then we choose we just type right for the language, we type EE, and then it already comes up the NER model. We copy paste our text. We get the German NER outputs. And we see already most of the German entities are properly detected and classified. If you want a more accurate or bigger model, right, you can type DE NER, and you see there are different variants, like there's a medium or a large one, which then will take longer to compute and will be bigger, but they will also have much higher accuracy. Now let's clear up our notebook a little bit. Just hit F5, which will reset everything. And now let's get to the embedding. And let's pick some additional similarity metrics this time. Let's use Euclidean. And let's use some birdology, bird embeddings. We want the English bird. Let's take Electra, another birdology embedding. And let's use Elmo. We get the similarity matrices for all pair of embeddings. So we have the glove similarity matrix and the Electra one, and further down we have the one for the Elmo and the bird. And we have one plot for each type of similarity metric. So we define the cosine one here and the Euclidean one here. And we see the similarity and meaning for each embedding has been encoded differently, and we can actually compare it. So let's actually use a proper example that really showcases you how the contextual embeddings work. So let's just type in both text fields hello, hello, hello world, and compare both texts to each other. We just type this here and hit enter. We get the similarity matrix for the words hello, hello world to itself. And we can see here, for example, the glove embedding, the word hello to hello to hello to hello always has the same similarity, because each hello token is represented with the same vector. But if you look at the Electra embeddings, which are contextual, you actually see there's more variety in the similarity matrix. And just by comparing these two plots, you know these are two different classes of algorithms. It's the same with the birth algorithm. See, it properly encodes the context, but Elmo, interestingly, it doesn't properly encode the context here for this example. But if you look very precisely, there are slight nuances and differences. And so to go to a more concrete and fun example for the dimension reduction, let's pick a bigger example. For example, we can search the architect script matrix. And now we get something fun to play around. If you just go to some website that has the architect script from the movie The Matrix, copy paste this all, configure MDMS, spectral embedding, SVD, and type here bird. And we can paste our text. And after a couple of seconds, we will have the dimension reduced version of all of the tokens. And now we can actually see the matrix in 3D, and also how all of the tokens are actually embedded and encoded by our word embedding algorithms. So here we can actually see how glove is embedding the words, and we see already with Tesla that it performs very nice part of speech clusters, because each color here represents the part of speech class, and the PCA does not perform so great, as well as the MDS. It's kinda okay, and the SVD and LSA is also not the best, but the spectral embedding is interesting, but again, it is not super discriminant. But now we get to the bird section. We can see Tesla is performing very decently, for especially in the 2D case, and for the PCA, bird is performing very nicely with the PCA. And we even see the clusters forming, especially in the 1D also. For the MDS, much better with the bird. So we can already see that somehow bird just encodes the vectors, right, much better. Also in the SVD, we see the clusters are forming much nicer. Finally, we also have the spectral embedding, and which again performs very nice. We see even in the 1D case, right? We have here this one group of the negative samples and then the blue for the part of speech. So now we can go back to the main slide. So there are a lot of features we could not cover today, especially on the NLU healthcare side, which has NER models for domains like clinical, anatomy, drugs, demographics, risk factors, and even sensitive data that you can anonymize, and even you can map the extracted entities into medical terminologies like CPT, RX norm, or even LOINC, and you can even assert the status of the entities and find a relationship between your entities. And you can visualize this with, here you can see a resolution algorithm or assertion and even the relation extraction. And here are a couple of nice magical NLU cheat sheets for all of the magical one-liners, a nice overview of the open source features, NLU resources, and the end of this presentation. So I thank you very much. Feel free to connect with me on social media and enjoy the rest of AI4. Goodbye.